The gradient of a straight line is its slope. So, although gradient is the word that we use in mathematics, what you need to think of is the slope of the line. So, is it steep? Is it shallow? What is happening with the slope? Is it positive? Is it negative? And so, a very easy way of being able to work out the gradient or the slope, and have a look. We call this M in maths. M for gradient, I know. It's not G. G is something else. So M stands for our gradient. So in this first case, you've got a positive gradient. It is going from the left to the right and going up. And have a look. We've got our rise and we've got our run. And in order to work out the gradient, if we know those two things, then we can just put them in and work out our overall slope of the graph. This one here is a negative gradient or a negative slope. Again, we have our rise and we have our run. And here's our rule up here. Gradient is equal to the rise divided by the run. Have a look there. You can see that the rise can be positive or negative and the run could be positive or negative. So we do need to make sure we know what we are looking at there. We have two special cases, if you have a look down here, for our straight line graphs. So when we have a zero gradient, okay, our graph is a horizontal line. And when the line is a vertical line, well, we don't have a gradient. There is no gradient, there is no slope. So we say that it is undefined. So these are our special cases. In this example, we're asked to find the gradient of the following line segments where each grid box equals 1 unit. It should be 1 unit. Okay, 1 unit. So we can see if we start at B, we're going down 1, 2, 3, 4, 5. So we go down 5, so that's a negative 5. That would be our rise. Our run goes across to A from there, and we go across 1, 2, 3, and 4. So we're going back 4. So the negative means going down and back. So our gradient here, or M, is equal to, well, it's rise over run. In this case, our rise is negative 5. Our run is negative 4. Negative and a negative make a positive. So it is 5 over 4. What about the next one? Okay, if we start at D and go to C, we are going to go up. That's our rise. We are going up 3 places. Our run, okay, we're going in that direction, so that's the negative direction. We're going back 1, 2, 3, 4, 5, 6, 7. So we're going back 7 places. So, and again, you could see we've got a negative gradient there. So you would hope that you end up with a negative answer. Let's have a look. Gradient is equal to M, which equals rise over run. My rise here is 3. My run is negative 7. So 1 negative there makes the whole thing negative. So negative 3 on 7. So the second one has a negative gradient, and the first one has a positive gradient. Find the gradient of the following lines. There's a couple of ways you could do this, but let's stick with our rise over run method. And so what I'm going to do, I'm going from this point here, which is 0, 0. I was always the origin, 0, 0. So to go from this point and across, I'm going across 2 places. And from here going up, I'm going up 4 places. So my gradient is rise over run. My rise here is a positive 4. My run is a positive 2. So overall it is 2. Was I expecting a positive gradient? Yes, I was. So that looks right to me. What about the next one? Okay, we are looking for, in this case, to go from 0, 0 through the line, through the point, 15 minus 5. So where is our triangle again? Again, I'm forming a right angle triangle there. So you should be able to see that to go from 0 to 15, my run is 15, and then going down from 0 to minus 5, my rise is negative 5. So remember, gradient equals rise over run. My rise in this case, negative 5. My run is 15. Negative 5 over 15 is negative 1/3. Again, was I expecting a negative gradient? Yes, I was. So negative 1/3 looks right there. In part C, it's one of our special cases, and there's not a lot of working out there. As soon as we see a horizontal line, which is what this is, it goes through y equal to 3, we can straight away say m is equal to 0. I have a 0 gradient. And the same goes for the next one. As soon as I can see a vertical line, which is what I have here, my gradient is undefined. So no working out for the last two, as long as you can recognise them. A lot of people don't like using the method rise over run. It confuses them a little bit. So when you're given 2 points, some people find it a little bit easier to use this rule here, where you have y2 minus 1, y1 over x2 minus x1. It really is the same thing as rise over run, but it gives it more formality. So here I'm going to use the rule for these two examples. So you can see I've got the point 1, 2, and my other point is 3, 8. What I'm going to do is just label my points as x1 and y1, x2 and y2. So remember, the 1s must be together, the 2s must be together. Doesn't matter if I had it called the first lot x2 and y2, as long as the 2s are together. All right, the rule here is just simply m is equal to y2 minus y1 over x2 minus x1, which is really just giving us the distances there. So y2 minus y1 would be 8 minus 2 over x2, which is 3 minus 1. And when you work that out, you get 8 minus 2 is 6, 3 minus 1 is 2. So my gradient there is 3, a positive 3. Was that aligned with a positive gradient? Yes, it was. And the last one here. All right, we have got the points negative 3, 4. So let's start off the same way, negative 3, 4. And we have the point 5, negative 1. All right, just to be different, let me call this one x2 and y2, just to show you that it still works. And then if this is x1, this needs to be y1. Again, it doesn't matter as long as the 1s are together and the 2s are together. So m, my rule is m equals y2 minus y1 over x2 minus x1. Substituting in, I get 4. Now be careful with your signs. Take away negative 1 over x2, which is minus 3. Take away x1, which is 5. All right, now negative and a negative make a positive. So 4 plus 1 is 5. Minus 3 minus 5 is minus 8. Can I simplify that down? Well, the answer there is no, of course, because nothing goes into 5 and 8. So I actually have one negative, so the whole thing is negative. It's a negative gradient. Looking at my graph, yep, I was expecting a negative gradient, so it looks right to me. This method being used in the previous examples where we used rise over run. As long as we've got 2 points on the line, then y2 minus y1 over x2 minus x1 can be used.